All right, so welcome to 13.4 on other integration methods. So here we're going to look at the trapezoidal rule, Simpson's rule, using a table of integrals, substitution in integral tables, reduction formulas, and finally applications. So approximation of definite integrals by left sums and right sums we've seen. It's instructive and important, but not very efficient. Now, a large number of rectangles must be used, and many terms must be summed to be able to get good approximations. Now, the trapezoidal rule and Simpson's rule actually provide more efficient approximations of definite integrals in the sense that fewer terms must be summed to achieve a given accuracy. Now, we also can have a table of integrals that can be used to find antiderivatives of many standard functions, and these definite integrals of such functions can therefore be found exactly by means of the fundamental theorem of calculus. And so in our book, what we'll have is we're going to have on page 915, 916, and 917 all these different integration tables. So we don't have to actually have them, try to calculate all of them. There's some that are already done for us, and so we won't have to always do that. All right, so going back here, what is the trapezoidal rule? Well, in figure one here, we can see we have a left right rectangle, and here we have the right rectangle. One of them overestimates, one underestimates. And then we have the one that's called the trapezoid. And so basically it's going from the left point to the right point, and it's cutting that amount here in a lot smaller. So when we're on this side of the curve, we're underestimating. When we're going to go on the other side of the curve, we'll be overestimating a little bit. But it's less than, this huge amount here or this bigger amount here. So it's a good thing. And so as we can see, the area of the left rectangle is f of x sub 0 times delta x. The area of the right triangle is f of x1 times delta x. And the area of the trapezoid is f of x0 plus the f of x1. And then we're going to divide it by 2 and then times the delta x. And the reason we use this is because the area of a trapezoid is found this way. Its area is 1/2 of the a plus the b times the height. So a is one side, b is the other side, and then times the height. And so that's why we're going to end up using this formula to be able to find the area of the trapezoid. Now note the area of the trapezoid in figure one is the average of the areas of the left and the right rectangle. So the average T4 of the left 4 and the right 4 for a function on an interval is equal to the sum of the areas of the four trapezoids. So think about this, if we did the left one, it would come here. And then if we did this one, it would come here. Then this one would come here, and then this would come here. And we'd have those four. If we did the right, it would come this way, and then this way, and this way, and then this way. And so what we're doing now is we're doing the trapezoids, and those are going to be kind of what we see here. So if we added the L4 and right 4 and divide by 2, you get the following formula. Well, here's our L4 plus the right 4, and we get T4 is this function here. So it's just f of x0 plus 2f of x1s plus 2f of x2s plus 2f of x3s, and then finally the f of x4 times our delta x. We're going to divide everything by 2 to kind of get that average. And so this is how we find T4 when n is equal to 4 for the trapezoid rule. Now, in general, how do we do it? Well, for the trapezoid rule, let f be a function defined by the interval from a to b, and we're going to partition a to b into n subintervals of equal length. And so basically, you take the upper bound minus lower divided by n, and we have our endpoints a and b. Then our t of n is going to be f of x0 plus 2f of x1 plus 2f of x2, and so on until we get to 2f of x of n minus 1, and then we just have only f of xn times our delta x divided by 2. Now that's an approximation for the integral from a to b of f of x dx. Again, this is using the trapezoid rule. So with that said, it says use the trapezoid rule with n equals 5 to approximate the integral from 2 to 4 of the square root of 81 plus x the fifth dx. Round the function values to 4 decimal places and the final answer to 2 decimal places. All right, so first things first, 4 minus 2 divided by, we're doing 5. So 2 divided by 5, so that's going to be 0.4. So that means if we kind of follow how the book does it, we're going to make a table. And this is going to be our x, this is going to be our f of x. So we're starting at 2, then we go 2.4, 2.8, 3.2, 3.6, and then 4.0. So that will give us, all the different intervals. And now we have to plug in 2 into this function, and then 2.4, and so on. And to save time and typing it, writing it out, I've written it out. And so this one is 10.630146. And again, I'm writing all of it, even though it says round to 4. I'm going to round to 4 when I do the calculation. And then this one was 12.673841. This one was 15.909233. This was 20.409417. This was 26.1851144. And this was 33.24154. So we are doing n is 5. So we want to find what is t sub 5. Okay. Well, what we say is we're going to take this one plus this one, and then plus each one of these times 2. Okay. And so we'll take, and now is when I'm going to round it. So that's going to be 10.6301 plus, now we have 2 times 12.6738 plus, then we have 2 times, and then we have 15.9092 plus, then we have that 2 times. It looks like 20.0094. Wait, 20 point, that's a 4, not a 0. I can't read my writing there. All right, 20.4094. And then we have plus 2 times, that was 26.1851. And then we have plus, too long a line now. And then we have our last one, which was 33.2415 and 2415, yep. And then we take it times our delta x, which was what? That's the 0.4. And then we divide the whole thing by 2. Okay. And so when you plug all that into our calculator, and again, to save time, since that's a lot of writing and typing into a calculator online, we end up with 38.85. Okay, so again, you have your parentheses around those for sure, and then you have this plus that times that. And you don't have to have a parenthesis here. You can just put a times. You can put a times here, and you can put times here, and put a times here. And then, all that times 0.4 divided by 2, or times just 0.2, that would work as well. Okay, so that is using the trapezoidal rule to find the solution to this problem. All right, so let's stop there and we'll come back for some more.